Come on, Danny, let's go. So this is worksheet 4.7, number 12. All right, so 12 said I have negative, in parentheses, y to the 5th times y squared. All right, this one is a little odd because it has that negative. But let me ask you guys something. If I have an x, what is its coefficient? If I have an x, what is its coefficient? Brendan? 1. Yep, that's a 1 times x. If I have a negative x, what is its coefficient? Colin? So this is the same thing as negative 1 times x. So keeping this in mind, if I was to rewrite number 12, some of you got this. This is actually negative 1 times y to the 5th times y squared. Matthew, you listening to this, please? So this is actually negative 1 times y to the 5th times y squared. Gentlemen, you're listening to me. All right, now I can multiply stuff. So I have negative 1 times y to the 5 plus 2, which is negative 1 times y to the 7th. I would take that, or it would be simply written as negative y to the 7th. Questions on that one? Yes. I'm sorry? Let me make sure I wrote down right. Well, it can't be to the 9th because this is 5 and 2. Well, I'm telling you, this is your answer. That is your answer. What else can I do for you guys? Amanda, does that help you? Excellent. What can I do for you guys other than that? Ada? I'm sorry? Do you not have a question? Okay. Does anyone have any other questions on these? Really? Okay. Put this away. Get your notes out. Danny, you don't have any questions on any of those. You didn't want me to practice any of them with you. You didn't want me to help you with any of them because I know that there was some of you guys, everyone's eyes are over here. How many of you guys over the last month have still felt a little bit of like unsureness of what you're doing? Okay? Then you need to be asking questions. If you have homework where you're like, I wasn't sure what to do, I was confused on something, and you're not asking me questions, how do you think you're going to get it right? Your job is to ask me questions. My job is to explain things the best I can to you, and hopefully I can do it the right way the first time and maybe the second time. So if you're having troubles on things and you're not asking me questions, I can't help you. So when you take your test, you haven't asked me questions. Why do you think you're all of a sudden going to get it if you didn't get it in the homework and you didn't ask me questions? I don't know what to tell you guys. You have to step up and start asking questions, even if you're uncomfortable asking them. If you want to ask me personally, and you have on your own time because you don't want to do it in class, please come see me. I've had several people come see me on their own to ask me questions on their tests, to figure out what they did wrong on the test and explaining it. On homework, to go through individual problems with them. On quizzes, coming and asking me questions on quizzes. I have a student in here that has now come in to start asking me questions on every quiz and every test, so that student knows what they did wrong. And I give that student a ton of credit. a ton of credit, because that student wants to learn this and wants to grow and wants to know what they did wrong. I give this student a ton of credit. You all should be doing that. Okay, we are starting scientific notation. So today is 12-12. All right, this is the last section in this chapter, so we're in 4.7. All right, this is going to take us a little while, which is why I don't have any homework. All right, because explaining this takes more than a bit of a class period. So what we're talking about is scientific notation. All right, so scientific notation is, it's a way of writing really big or really small numbers. You see this in science, scientific notation, science all the time. All right, so, and we're going to explain how to do this, but if I had 1 million, how about 1 billion? Let's make that 2 billion. If I had 2 billion, and I needed to multiply that by 750,000, that would be super ugly, wouldn't it? Like really super ugly. All right, so don't. Write those numbers easier. This, in scientific notation, would be 2 times 10 to the 9th. 2 billion written out, we call that standard form. 2 times 10 to the 9th, that is called scientific notation. All right, so I need to first talk to you about what scientific notation looks like. There is a very particular format in which it's scientific notation. How many of you guys have seen this? Okay. Alex, can I see your calculator? So some of you probably have tried to do a calculation, and you've looked at your answer and you've been like, what? All right, so let's say I have 2 billion, whatever it is, times 500,000. There's my answer in scientific notation. All right, on my calculator, thank you, sweetie. Different calculators show it in different ways. So on this calculator, AJ, just give me a second, please. My calculator says that. 4.485E15. That E means exponent, and that's the exponent on your 10. So if you were to look at that, E refers to the exponent on your 10. So that would be 4.485 times 10 to the 15th power is what that would look like. So when you're using a calculator and you get that crazy thing, that's what that means. AJ. Excuse me? Yeah, so that's what the E is. The E means exponent. So let's talk about what scientific notation looks like. All right, so I'm going to kind of write one. So I have let's say 2.3 times 10 to the 5th power. This is just a random scientific notation number. All right, I'm going to take some notes over here. First of all, scientific notation is the multiplication of two factors. So it's the multiplication of two factors, all right? Those two factors have very specific rules that go with them. This first one is our first factor. So that's our number one factor. The second one is going to be our second factor. So this is our first factor. This is our second factor. The multiplication will always be an x. Always x. Or that multiplication symbol that is an x. It's not a dot, it's not parentheses, it's not a star, it's always going to be an x. That's the last, this is like the last time, the last one place that you're going to see x for multiplication is in scientific notation. So let's talk about the rules for our first factor. So our first factor is a number. So it's a number between 0 and 9. We have a single digit before the decimal. So we have a single digit before the decimal and any number of digits after. Or no digits after. If you notice in the first one, I said 2 times 10 to the 9th. So I don't need any digits after. I have to have a single digit before. That is a requirement. You have to have a single digit before the decimal. All right, our second factor, it's always 10 to some power. So our second factor is always 10 to some power. All right, that power can be negative or positive. And we always leave negative powers. Always leave negative powers. So we could have something like 3.2 times 10 to the negative 4th. That would be what a negative power would look like. Or we could have 3 times 10 to the 5th. That's what a positive power would look like. Those are both scientific notation. And those are proper scientific notation. Are you guys good so far? Okay. So what we are going to be doing tomorrow, and I need to have you guys wrap your head around this. I'm not done. All right, I need you guys to wrap your head around where we're going to go tomorrow. All right, what I want you guys thinking about is we are going to be comparing the size of standard form to the power we need to use. That's what we're going to be comparing or attaching. All right, I'm just going to give you a quick, because I want you thinking about this. Bigger standard form positive power on the 10. So bigger standard form means bigger than 10. So any number bigger than 10. All right, smaller standard form that means any number between 0 and 1. We have a negative power on the 10. We're going to pick up on that tomorrow. So if we have a number bigger than 10, 15, 400, 5,232,000, all right, bigger numbers, when we change them into scientific notation, our power is going to be positive. Smaller numbers, 0.00563, 0.24. Those, when we change them into scientific notation, are going to have negative powers on them. And we always leave the powers as negative, okay? Cullen.
What if it's like 5?
Then it's already in standard form. Like, it's already in scientific notation. That would be like 5.4 times 10 to the 0 power. Because it's already, that we wouldn't change those. So scientific notation, we use them for really, really big numbers or really small numbers. These really big numbers is anything over 10 or anything between 0 and 1. Anything that already has a single digit in the ones place, we're not going to write a scientific notation.
Okay.
Does that make sense?
Yeah.
Okay. You guys, odds can go.